You throw a stone off a cliff horizontally at a speed of 14 meters per second. After 2.4 seconds, the stone hits the ground below the cliff. What is the initial velocity of the stone? What is the velocity of the stone just before it hits the ground? What is the speed of the stone just before it hits the ground? Okay, so draw a diagram for the problem. So we have a cliff, and this is U. And so we're initially throwing a stone this way, and it falls like this in an arc, parabolic arc. So we're told that the initial speed of the stone is 14 meters per second. And you have to find V final. At a time of 2.4 seconds. Okay, so our general equation, so our first problem is, what is the initial velocity of the stone? So we have to do a coordinate system. I is going to be, and j is along the x-axis, j is along the y-axis, and I is along the x-axis. So V initial is going to be, 14 I hat meters per second. Acceleration due to gravity is g. So the equation you're going to be using is going to be V final is equal to V initial plus acceleration times t. So V initial is going to be equal to, let's call it VO temporarily. VO, so this is really VO I hat. I hat plus acceleration is down, so it's minus GJ times time. And so we're left with VO I hat minus GT J hat at any time, V final. So we can find the final velocity just before it hits by just plugging in numbers. So V final at t is equal to 2.4 seconds is equal to, at t equals 2.4 seconds is equal to VO, which is 14 I hat minus 9.8 times 2.4 seconds times j hat. So bring out your calculator. So the initial velocity is part 1, part A. So this is going to be 9.8 multiplied by 2.4 equals 23.52, or 14I minus 24 j hat. Two significant digits is the answer. So the final just before it hits is part B. So it's traveling 14 meters per second. I just forgot to put the units in, so this is meters per second units. 14 meters per second this way and 24 meters per second down, so it's roughly going down like this, just before it impacts the ground. Okay, so what is the speed of the stone? Vf is going to be the speed, and that's equal to the magnitude of the velocity vector. So this is called the speed, part C. And that's equal to 14 squared plus 24 squared, which is correct. We have to correct it to 14x squared plus 24x squared equals, I'm taking a square root, 28 meters per second. So the speed is 28 meters per second. The velocity vector is 14 I hat minus 24 hat. The magnitude of that is the speed, the instantaneous speed.